So thank you for joining us for our 14th installment of the webinar series. In this edition, we'll be talking about Wi-Fi enterprise security software. And what this will cover is the addition of cipher suites that are specific to enterprise conditions, and we'll describe in detail what the difference is between an enterprise scenario versus a home scenario, which is what most of us are used to. We'll talk about what roaming is and how that's important in enterprise configurations for Wi-Fi, and we'll introduce some new features to Microchip's products. So what is our mission with this software? Our mission is to provide more options for security that allows your products that use Microchip's Wi-Fi to gain access to Wi-Fi networks within buildings and campuses. We want to make more reliable connections, and we'll describe how we do that and add more functionality as well. So at this point, I'd like to introduce some terms that are going to be used throughout this presentation. They may be familiar to you, or they may be completely foreign to you. So I thought it'd be good to go over them just to set the baseline as we go forward. So throughout the presentation, you'll see the term AP, which of course means access point. We're pretty familiar with that if we're using Wi-Fi. You may see STA or station. That's the end node. That would be the product that you're designing with a Microchip module. You'll see WPA2, which is Wi-Fi protected access. That's the method of establishing security to gain access to the network. You'll see SSID, which is the service set identifier, and that refers to essentially the access point's credentials. You'll see TTLS, which is tunneled transport layer security. You'll see MS-CHAP, which is a quite old, actually, Microsoft protocol for authentication. You'll see the term EAP or EAP, and this is standing for Extensible Authentication Protocol. You'll see PEEP, which is a variant of that, which just means Protected EAP. You'll see the term roaming, which is the ability to move from AP to AP without re-entering a password. And you'll see NTP, which is Network Time Protocol. So those are just some terms that I want to make sure I explained a little bit as we go through this, because we're not going to take the time to talk about the full definition. If you'd like to learn more about these topics, I recommend that you simply Google Wiki PEEP or Wiki NTP, and you'll get a lot of information about all of these terms and protocols and what they mean. Also, it's important to go to microchip.com/ATWink1500, and on the next slide, you'll see what the 1500 is, but in that page, there's software release notes that describe exactly what's supported from Microchip in terms of authentication protocols. So now that we've established a baseline of what we'll be talking about throughout the presentation, let's move forward. So first off, what are the products that support enterprise software from Microchip? So we have two products. One is a straight Wi-Fi module. It's called the ATWink 1500 series. There's a 1500 and a 1510. And the products have the ability to have different firmwares. And the firmware versions that support enterprise software are 19.6.1 and later. That's easily identifiable by the ordering code of that device. And for our 3400, which is Wi-Fi plus Bluetooth Low Energy, it's 1.3.1 in later versions. All right, so let's start to differentiate what we mean by enterprise from what's a normal home scenario. So here I have a access point in the red box, and it's inside a home. And this is a typical configuration for what many of us are familiar with. So there's a single access point, and there might be multiple stations throughout the house. And the stations keep within the range of that single AP. So the little guy's moving around the house, or he could represent different IoT type devices that are positioned throughout the house. They're all within range. So the blue circle is meant to show that it's in range of that access point and the stations never leave that sphere. In this case, WPA2 personal security is what's generally used in this scenario, and it's quite straightforward. We're all familiar with how to gain access to our home networks. There's only one SSID and one password that's required typically in this scenario. And of course, this is our home environment. So we're very familiar with this. So how is that different than an enterprise type setup? So here's what it looks like when you're outside of the home. So once you leave your home and you go to different enterprise locations, so say this is a single corporation with multiple sites throughout the country or globe, or this could be a campus, for example, like a university campus that has multiple buildings. You start to have new challenges. One is physical location, and the other is the requirement for stricter security. So as our station or the robot moves to the first location, the interesting thing is he tries to gain access to that network, but something comes up. It requires something called TTLS and MS Chat version 2 to gain access to this network. So this is a component of what's called WPA2 enterprise security. So because our station or robot doesn't speak TTLS, MS Chat per se, because he's used to the home environment, he can't gain access to that network. So moving on to a second location, now this location requires yet another cipher or protocol called EAP-PEEP. And once again, he doesn't understand that cipher and can't gain access. So you require a matching protocol to join that network, and we don't support that if we're a personal area network software load. So we move on again. And now there's yet another one called EAP-TLS. So at this point, you're seeing that at these different locations, there's different ciphers that have been deployed. And so the station has to be, call it multilingual. It has to be able to understand the ciphers that are at each location and authenticate against those. So we move on to the last one, which is EAP-PEEP-TLS, and the same thing happens again because there's a mismatch in what it can understand. We don't gain access to the network, and so we've really failed in all four scenarios to gain access to any network as a station in this case. So what do we do? Well, if you use enterprise software, so enterprise security software, that the difference is instead of a personal area network, it's set up for enterprise. So now it does actually understand each of these ciphers. So when you move over to our first case, we understand that because within WPA2 Enterprise, which is available again on the AT-Wink 1500 or AT-Wink 3400 modules, Wi-Fi modules, those ciphers are programmed into the firmware and allow you to speak that language, if you will. So we understand that protocol, we can gain access to that location. And the same thing happens as we move through each of these other locations that have different ciphers. We can speak their language. And another important thing is that in each of these locations, there could be a different brand of access point. So in addition to being able to speak each of those ciphers, we've also interoperability tested with 90% of the access point chipsets that are in the market. So that just further ensures that you're going to gain access to that network. So how does this help us? Of course, it saves effort because one case would be if you wanted to gain access to any of these enterprise networks and you had the personal version of the firmware, you would have to do a lot of extra work on the host side. So we've taken care of that through our firmware to prevent you from having to do extra work. You just simply call that cipher and you can connect. So what is the big benefit of all this? Well, first of all, it's easy to manage devices that are being deployed into this enterprise or campus environment, and it makes it much easier, similar to how companies manage laptops. So with enterprise software, we can successfully connect to all of these different ciphers. We have interoperability testing that ensures a reliable connection. And obviously, this allows your product to be deployed a lot more seamlessly into environments such as this. So we talked about security ciphers, and once again, more reading can be had if you go to the software user guide for AT-Wink 1500. It's located on its product page, which is found at microchip.com/AT-Wink 1500. That'll tell you all the different ciphers that are supported, but the interesting thing is that's not all that's required to ensure good connectivity on a large facility such as what we just reviewed. What else is required? Well, if we look at the scenario of this factory, what you can see with the little blue antenna symbols is there's multiple stations at this location because it's such a large physical area. So while our little computer, our little robot station guy can connect to his nearest access point, if you look at the access point that's all the way across the campus, he doesn't have a connection to that access point and would not be able to because of its physical distance away from its position. So what do we do in this scenario? How do you navigate this large area and keep a Wi-Fi connection? Well, that's what we call roaming. So here's what it would look like without roaming. So in this case, you're connected to access point 1, and as you move away from the access point into the range of a second access point 2, without roaming, you're going to remain connected to access point 1. The problem with that is your signal, as being shown by the green signal indicator, is going down. So you're starting to lose connectivity. So when that happens, you start to miss the beacons that are sent out by the access point, and that's what maintains your connection. So as a result of that, you're going to lose that connection. What happens after that is that there's a lost connection and you close the socket. So now the data streams that you were sending to the cloud and your TCP sessions will be severed. So now, if you're in range of a second access point, the host, your station or your application is going to have to rescan and connect with credentials that have to be re-entered. So it's an interruption, essentially, of the operation of the device. And what's going to have to be required is that you're going to have to write software that'll ensure that you can reinstate that session as you move throughout the facility. So it's a lot more effort. It's a potential for lost data, leading to a bad situation. So without roaming, we're continually going to be reconnecting to different access points. So here's a scenario when we now have roaming. So as you move from access point 1 to access point 2, what happens is the station, our software running on the Wink 1500, will detect that our range is extended. We're at an extreme range from the access point. So as a result of that, we are going to be scanning for new networks that are in a better range situation. So we'll scan for nearby access points that are part of the same network. That'll allow us to preserve IP connections while we're searching. So we're continuing to send data to access point 1 while we're detecting this extreme condition. And in the background, we're also looking to connect to a second access point so we can continue to stream that data. We're going to join the second access point and drop the connection with the access point 1. And because of automatic roaming, we don't interrupt our TCP session or data stream. So we continue to send that data to the cloud. So that's roaming. So you can see that between the cipher suites that allow us to gain access to the network, and roaming, which allows us to move physically around a large campus, we now have a much better solution for enterprise, meaning large businesses or campuses or large physical locations. So that's two pieces of the coverage that we have with our enterprise software. Now to continue, there's a couple of other things that are part of this new software that are just additional benefits to enterprise installations. So one is NTP servers. So whenever you're going to connect to a server, you need to provide network time. And this is part of the authentication process, in fact. So in this case, we're trying to connect to a server. The server is going to say, what is your current time? And in our prior software, we had a fixed set of network time protocol servers that we could pull from. So we would talk to those servers, find out network time, and then provide that time. Well, oftentimes those are not available. So if those servers happen to be down, we would not be able to provide the time, and then we would not be able to connect to any other servers, so our authentication will fail. It doesn't allow us to make a connection. So that's pretty annoying to your user of your application because now they have to retry or modify their firmware. Not an ideal situation. So in this software, the enterprise software, we've updated that to allow for a lot more flexibility. So when the internet server says, I need your clock information, we can pull from a variety of NTP servers that are customizable and dynamic. That allows us to provide the time, and we can be connected and matched and authenticated. So that's yet another enhancement for our enterprise Wi-Fi software. And then the last topic I'm going to touch on is having to do with deploying products in a global environment. So you may be working on products that are going to be deployed in North America. They may be deployed in Europe or maybe in Asia. And the interesting thing about Wi-Fi and RF is that the standards vary across the globe. So what I'm showing here are 4 regions. We have region A, region B, region C, region D. And what you see in the green is the RF power specifications for each of those regions. So you can see that region A has substantially lower power regulations than region C. What does that mean? So output power, when in terms of RF, if you're not familiar with it, has to do with basically how much power are you transmitting. So that is going to affect your range, and that's going to affect your connection quality. So each part of the globe has a different specification for that. So region C may allow you to have a much further range and have a better connection over that range. So we were looking at access points just a minute ago, going from access point 1 to access point 2. If you're in region C, maybe you could go quite a bit further away from that access point 1 before you start to lose the connection. With region A, you would lose that connection a lot sooner because you're not allowed to output as much power. So hopefully that helps you understand what is meant by RF power. So in this latest software, we provide 4 regional settings. Why is this important? Well, now we'll turn our attention to the red bar. So you could see that in the past we had, well, I'll explain. In the past we had one setting for power that would apply for the globe. So what did you have to do in that scenario? You had to output the power that would meet the specifications globally. So if you look at region B, where we've taken the red bar, which represents the power output of a Wink 1500 with the old firmware, it's matching what the regulatory or green bar says it can output. Well, if we want to deploy that into region A, C, and D, we can't increase our output power because we will violate region B's specification. So the solution to that is to provide multiple regulatory domains so that we can provide different output powers depending on where we're located. So this is now showing what it looks like when you use the enterprise Wi-Fi software. You can see that now our output power, which is the red bar, is matching the regional RF regulation, which is the green bar, in each of these locations. So again, why does it matter? It matters for range, it matters for connection quality, and it matters that you can now physically separate devices more in region C than you could in region B. Okay, moving on from that, one last thing I wanted to talk on is over-the-air updates. So with our Wink 1510 device, we actually have a large area of flash that's available for the host. So if you want to do over-the-air updates and you have a small memory-sized host, we can actually store a image so that you can do upgrades to that firmware through our Wi-Fi module. So what does it do? It's a space for maybe you want to store device info or sensor data that's local. So it's not having to do anything with OTA. Or you may want to do the OTA image for your host in that space. You may want to host something that is quite large in memory. So when a person connects to the device, you may want to display an interesting web page or image or logo on the web page that you serve to the device that's connecting to it. Or you may want to store some kind of proprietary data. Maybe you have a serialization for your product or a specific code that you're going to store in each device that's unique to it. So all those things can be stored in this extra flash that's available on the 1510. So that's an enhancement that comes along with this firmware as well. So just summarizing all the benefits of the enterprise software, you have more Wi-Fi infrastructures that are supported. You can go from a personal area network to now buildings and campuses. We have customized NTP servers. We have more regional RF flexibility to match what the regulatory is in those environments. We can meet more system requirements. So if you're trying to deploy your device in different geographies, in different physical type of locations, we give you more flexibility to do that. And in the case of very large campuses or buildings where there's multiple access points, we have automatic roaming that allows you to reconnect seamlessly without intervention of the firmware. So the bottom line is we allow you to operate in more physical environments.